Hi everybody. So on today's show we review for our Unit 3 assessment on linear functions, which is tomorrow. So you need to have done these practice problems and have mastered them because they're going to help you on tomorrow's test. So which scenario can be represented by a nonlinear function? Well, what makes a function linear is a constant average rate of change. Linear functions are based on repeated addition. We add that rate of change every time. So a water tank is filled at a rate of 2 gallons per minute. That says each minute we add 2 gallons. This is linear. That is not the answer, because that is definitely a linear relationship. A vine grows 6 inches every week. Each week we're adding 6 inches, so that's linear. Two's out. 3. A species of flies doubles in a population. Doubles is implying multiplication by 2. 2, 4, 6, 8. It's doubling. That's not a constant rate of change. That rate of change is changing between 2 and 4 and 4 and 8, and then 8 and 16. The rate of change is growing there. It's not constant. It's not the same number, so 3 is not a linear function. A plumber has a set fee for a house call and charges by the hour for repairs. The total cost of her services can be modeled by C of t. So C of t here is a linear function. We have a slope of 125 and a y-intercept of 95. So which statement about this function is true? Does the house call fee cost $95? The plumber has a set fee for a house call. That set fee there is the y-intercept. Number 1 is true. The plumber charges $125 per hour. That's our slope. That's our rate of change. That is a true statement. The number of hours the job takes is represented by t. Yeah, because we're paying 125 for every t. So all 3 statements here are true. All 3 statements are true. Make sure you're able to describe and explain the meaning of the slope and y-intercept in the context of the problem by saying that y value is the initial fee, the initial cost, and the slope is the rate of change for every x, what's happening to y. Speaking of rate of change, find the average rate of change between 2 and 7. So average rate of change is we want to find the slope between those 2 points, 480 minus 140 over 7 minus 2. Our change in y over our change in x, 5, that gives me 340. 340 divided by 5 is 68 what? Well, it's 68 miles per every hour, so it's the units here are miles per hour, because I had 340 miles over 5 hours. That's an average of 68 miles per hour. You need to be able to find slope, change in y over change in x, our rise over our run, using tables, equations, and graphs. How many of the equations listed below represent the line passing through these points? Well, to write the equation of a line passing through 2 points, I need a slope. So let me do change in y, negative 7 minus 3, over 4 minus 2. Negative 10 over 2 gives me a slope of negative 5. Well, I don't know what the y-intercept is, so I'm going to pick a point. I'm going to use this point here just because I see that point popping up in the choices. So it's y equals negative 5 times, using point slope form, x minus 4, I want to take away 4, and then we stick that y value outside. If I was to simplify this, that would give me negative 5x plus 20 minus 7, which equals negative 5x plus 13. So choice, this equation here looks good. The top equation, y is not by itself. So to get y by itself, I'm going to subtract 5x and get y equals negative 5x plus 13, which is the same. So that top equation also works. I notice that this equation has a slope of 5. There's no way that one works because I want a slope of negative 5. And that second one, if I subtract 7 from both sides, it lands me at my point slope form. So that one's good. So there are 3 solutions, 3 equations here. The first one, the second one, and the third one all represent the equation of a line between those 2 points. Sue and Kathy were doing their algebra homework. They asked to write the equation of a line that passes through the points negative 3, 4, and 6, 1. Sue wrote that equation and Kathy wrote that equation. Well, Sue used point slope form. Sue says y equals negative 1/3 x plus 3 plus 4. I added 4 to both sides there. Kathy used slope intercept form. So to check that they're the same, I'm going to distribute. Or you could have just went to your calculator and saw that these lines pass through those points. That works too. When I distribute, I get negative 1/3 x plus 3. So clearly these two lines are the same. And this line does pass through the point negative 3, 4. And if I was to find the slope between those 2 points, change in y, 1 minus 4 over 6 minus negative 3, that gives me negative 3 over 9. That gives me a slope of negative 1/3, which both these lines have. So because this is the correct point slope form, it has the right slope, passes through that point, and I distributed to get slope intercept form, they are the same. They are the same line, but you could have just went to your table and said, look, this table passes through those points, that table passes through those points. One characteristic of all linear functions is what? Linear functions grow by equal differences over equal intervals. What that means is we're talking about our slope. If I go over a certain change in x, my change in y has to be the same. If I have a line here, if I go over that same change in x, let me, not too far. I'm going to erase that line I just drew there. If I go over that same change in x, there's my change in x again, my change in y has to be the same. I have equal differences. My change in y is always the same if my change in x is the same. It's describing the slope. If I go over 5 units and up 15 units, when I go over 5 units again, I still have to go up 15 to create that linear pattern. So linear functions have a constant rate of change, but they also change by equal differences over equal intervals. Grisham is considering 3 situations below. Which of the statements describe a situation with an equal difference over an equal interval? Well, that's code word for saying a linear function. Equal differences over equal intervals is saying which of these are linear. For the first 28 days, a sunflower grows at a rate of 3.5 centimeters per day. That sounds good because we add on 3.5 centimeters. So the first one is totally a linear function. The value of a car depreciates at 15% per year. Well, if something's changing by a percent, that has to deal with multiplication. If something's changing by a percent, that has to deal with multiplication. We're multiplying there. So 2 is not linear because linears have to deal with adding, not multiplying. And the amount of bacteria triples. Triples is the bad word there. I don't want to multiply by 3. So only 1 is the linear function. It's the only situation that grows by an equal difference over an equal interval. The graph of an employee at a gas station. The graph below was created by an employee at a gas station. Which statement can be justified using the graph? If I buy 10 gallons of gas, it does not cost me $35. That is a false statement. For every gallon of gas purchased, $3.75 was paid. So I bought 2 gallons. 2 gallons was $7.50. 2 gallons was $7.50, which is 3.75 over 1 gallon. So each gallon does cost $3.75. Let's see why the other ones are ridiculous. For every 2 gallons of gas, $5 was paid? No. It's more than $5. If 0 gas was purchased, 0 miles were driven. Well, this has to deal with the cost and the number of gallons. It has nothing to do with how many miles I drove. So 4 makes no sense. 2 is the answer. In 2013, the USPS charged 46 cents to mail a letter up to 1 ounce and 20 cents per each additional ounce. So if I bought 1 ounce, if I have a letter for 1 ounce, it's costing me 46 cents. The pattern then is to add on 20 per ounce. There's my slope. I am not given the y-intercept in this problem. I am giving a point here. So I'm going to have y equals, I'm adding 20 each time to x minus 1 plus 0.46. I have to use that point slope form here because I'm not given the y-intercept. You could go backwards and get it, but the y-intercept is not given. And don't forget, use the variables that are given. They called it c of z. Tomorrow, if I ask you to write c of z, I don't want to see y equals. I want c of z equals, and I don't want x, I want z. So the answer is choice 4. Which table of values represents a linear relationship? Well, linear functions grow by equal differences over equal intervals and have a constant rate of change. What makes me linear? A constant average rate of change. So we look at the pattern. We look at the pattern here. Well, that's adding 1. That's adding 3. That's adding 5. That's adding 7. Is my rate of change here? Well, these are all plus 1, so we lucked out there. Is my rate of change constant? No, it's not choice 1. If you look at 2, you'll notice, wait a minute, that's a times 2 pattern. Linear functions have to deal with adding, not multiplying. And if you notice, the rates of change are not constant either. That's plus 2. That's plus 2. This looks promising. That has a constant average rate of change because my change in x's are all 1, 1, 1. The owner of a small computer repair business has one employee who is paid an hourly rate of $22. The owner estimates his weekly profits using this function. So we input how long the worker works for, and we output the profits. What is x? X is how many hours he worked for, because he's getting paid $22 for each hour. So what's x? How many hours he worked. Let g of x equal 2x minus 4. On the set of axes below, draw a graph of y equals g of x. That just means graph the function. All y equals g of x means is please graph the function for me. Well, this is a linear function with a y-intercept of negative 4, 1, 2, 3, 4, and a slope of 1, 2, 3, 4, a slope of 2 over 1, which means go up to right 1. Up to right 1. I'm doing this quickly, but your points would be much nicer than mine. So slope is change in y over change in x, our rise over our run. It's measuring the rate of change. How is my function changing? There is approximately my line. It's a little hard to do it on the computer. It's a little hard to do on the computer here. Let me just get it perfect. I want to go up to right 1. Plot the points, and you'll be good to go. I'm really off up here. Hold on a second. Let me start over. Let me delete that. Undo, undo, undo. We'll undo all of that. So the pattern is up to right 1. There we go. It's gone. So if I take my line here, I want to go from my y-intercept up to right 1 through all of these points that I drew. Don't forget arrows on the end of the line because I didn't tell you what interval to graph it over. It doesn't hurt to label it either. The last question, Caitlin has a movie rental card worth $175. That's her initial amount, that's her starting value, which means it's a y-intercept. After she rents the first movie, the card went down to $172.25, so she lost 2.75. Then she rented another movie and it went down another 275. Then it went down another 275. So assuming the pattern continues, write an equation for a of n. You have to use the variables. Do not write y equals. You have to say a of n equals, well, my slope is negative 2.75, not x. N is my input, n rentals, not x rentals. She started at plus 175. Caitlin rents a movie every Friday night. How many weeks in a row can she do this so she has no money on her card? So if she has no money on her card, I'm going to set it equal to 0 and solve. Subtract over the 175. And then when you divide, you get a lovely, lovely decimal. When I divide here, I do negative 175 divided by 2.75 and get 63.63.63. So we get 63 and some numbers. But she can't buy 0.63, 0.63, 0.63 of a movie, so she can only buy 63 movies. Explain how you arrived at your answer. I set the function equal to 0, I set the equation equal to 0, and solved. You have to write that out in words. So study, look over your notes, look over this. I owe a couple people some shout-outs from getting Kahoot mastered last time. So Mar, you get a shout-out from period 5, and Maddie Peck, you get a shout-out from period 7 for winning Kahoot during Unit 2, during our Unit 2 review. So nice job. We'll have some more shout-outs hopefully after this test. See you tomorrow.